Okay, so I'm going to talk to you about prime factor decomposition. So in an earlier video, I described to you what a composite number is. So basically, any composite number is a number that's not prime. So the other name for it is non-prime. Now, what's absolutely fascinating, or what I find absolutely fascinating about this, is that all non-primes are actually constructed out of primes. And how we work out which primes make them is called a prime factor decomposition. So let's break this down. A decomposition is the verb to break down. So we're going to take a prime and break it down by its factors. So a prime factor decomposition is taking a composite or non-prime and breaking it down into its factors, and those factors have to be primes. So for example, if I had 64, what I can do, is use a prime factor decomposition tree, and I think that's one of the easiest ways to go about it. Basically what you do is keep splitting it up into pairs of factors that multiply together to make that number. So I know that 64 is 8 times 8, so I'm going to write down 8 times 8. Just remember, when we're working with factors, we're multiplying, not adding, so they need to make sure that the two numbers you break it down into definitely multiply together to make it. So now I'm going to do 8 times 8, which I'm going to call 2 times 4. Now 2 is a prime, so I'm going to get another colour and I'm going to circle it to make it really stand out. Now I'm going to break down 4 further, and 4 is 2 times 2. Now notice that these are also prime. Now the great thing is, because I've chosen a square number, I can basically copy this side over onto this side. So if I break it down further, I'd have 2 times 4, and I know that that 4 is going to break down to 2 times 2. And then I'm going to go through and check for any primes. So 2 is a prime, another 2 and another 2. So actually, if I wrote all of these prime numbers down and times them together, so I've got 3 2's this side and 3 2's this side. So technically I've got 2 to the power of 1, 2, 3, 4, 5, 6. Let's check that. 1, 2, 3, 4, 5, 6. So if I worked this out, 2 to the power of 6, I should definitely end up at 64. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So yes, 6 to the power of 2 is my prime factor decomposition for the number 64. And that's all there is to it. The thing that catches people out is, you're probably told by your teacher to just keep dividing through by 2. But then what that does is it lures you into a false sense of security. So when you get to a number that isn't divisible by 2, you panic and you stop. So please, please, please get into the habit of trying to find other factors rather than just dividing by 2 straight away. So in this case, I knew 64 was 8 times 8, so I started there. It doesn't matter what numbers you start with, as long as they're true factors, it will always end up breaking down into the same primes. The primes that you end up with will always end up being the same, no matter what your original 2 breakdown numbers were. So just to reiterate, composite or non-primes are always made from multiplying primes together. And that finding out how you do that is called a prime factor decomposition, because you're breaking the non-prime down into its prime factors.